In this screencast, I'll be showing you one of the other very powerful features of Microsoft Excel, and that's the ability to put an equation or a formula inside of a cell. So let's say I wanted to do a simple addition. I could do 1 plus 3. Now doing it in my head, that tells me it's 4, but let's just check it anyway. So we start by typing an equal sign, and then we type the formula that we want. So 1 plus 3 should give us 4, and when we press enter, that's what we see. So I'll just click back on the cell, and up here is called the formula bar, and we can see that the formula itself is preserved, and it's just the result of that formula, which is what's displayed in the cell. So let's do some other basic math operations. Let's do a subtraction. So 10 minus 3 gives us a 7. 3 multiplied by 4. Excuse me. Our multiplication symbol here is an asterisk, not a X or anything like that. It's an asterisk. So that gives us a 12. We do 15 divided by 3. Our division symbol is a forward slash. We can do powers, so 6 to the power of 2. Our power symbol here is a caret. We can do a square root, so our square root is an SQRT of whatever value. So this is called a function. We'll go into more depth on functions next week, but mathematical functions I think are quite straightforward to use. So we type SQRT, open brackets, the value that we want to square root, and then close brackets. We can actually use brackets inside of math. So let's say we wanted to do 3 plus 4 multiplied by 2 minus 5. So let's evaluate this by hand first. So Excel follows the same order of operations that you were taught in math. So that's usually BOMDAS or PIMDAS, depending what you were taught way back when. And so what that is, we do whatever's inside of the brackets first. So 3 plus 4 equals 7. We've got no powers. Multiplication is by 2, so 7 multiplied by 2 is 14. And then 14 minus 5 equals 9. And that's the value that we get. So by itself, this probably isn't particularly useful because we can just grab out a calculator and do the exact same thing. But what we can do inside of these formulas is actually reference other cells. So I'll do a very basic example right here. I'll add whatever's in cell C1 to whatever's in cell C2. So I might put a 5 in here and a 12 in here. And what we can do is type equals C1, and that references cell C1, and we can see that C1 is changed to blue here and has a blue border, so it's very easy to find. And we add it to cell C2. So we don't actually have to type it. We can just click on the cell and it'll put it there. But you can do whatever you feel more comfortable with. When we press enter, we get 17. So the good side of this is that we can come back and change these values. So I'll change this one to an 8. And the answer is automatically updated. So just having those cell references there keeps it updated. So I'll take this to a bit of an extreme. So I'm going to jump to sheet 2, where I've already done some work. And in this chart here, we can see a parabola. And we've got an x-axis and a y-axis. And we've got an equation that defines the shape of a parabola. So y equals ax to the power of 2 plus bx plus c. Now for this particular parabola, we've got the values 0.5 for a, 1 for b, and 5 for c. Now you could implement this and work out for any given value of a, x, b, and c what your value of y would be. But I'm going to change it up a little bit and go with this equation. Now this is the equation that tells us where this parabola actually crosses the x-axis. So we can see here it crosses at 2 points. It crosses here, which is about 2.5, and it crosses here, which is a bit over -4. So Going through this equation, we've got minus b plus or minus, so 1 for plus, 1 for minus, that's why we have two answers. Plus or minus the square root of b squared minus 4ac, and all of that is over 2a. So for x1, I'm going to have the positive version, so I'll start with an equal sign. I've got to put a bracket in because everything on the top row is divided by 2a. So we've got minus b, so cell b2 is our b value, plus the square root, so we can use a function inside of a formula as well. It doesn't have to be the sole part of a formula. So plus the square root of b2 squared minus 4 multiplied by a multiplied by c. And so close brackets for the square root, then close brackets for the whole thing. So then what we want to do is divide that by 2 multiplied by a. Now we have to put brackets around the 2b, the 2a, sorry. This is because if we don't, it thinks that we're trying to multiply the top line by b1. So just divide it by 2 and then multiply by b1 or by the value a. So we just put brackets around that and that fixes it. And that's apparently not a number. Oh, I know why. That's because our value for c is not positive 5, it is negative 5. And yeah, so a positive 5 value there would just mean that that couldn't evaluate. So negative 5 there and everything works. So the first point where it crosses the x-axis is 2.3, which would be this one here. So I thought it was about 2.5, so that's fairly close. And let's do it for this side. Now instead of just typing it out again, I'm going to copy and paste it into this cell and just change that to a minus symbol. So and our other one is minus 4.3, which is once again pretty close to what I thought it was going to be. So there we have one of the more powerful features of Excel, where we can make some fairly complicated equations and see what they evaluate as. We saw what happens when we've got an error, so I'll just change this back to positive 5. So it says hash num exclamation mark. So if we click on here, it says that there's number error. This is I'm trying to do the square root of a negative number. So there's no square root of a negative number without going into imaginary numbers, which is sort of outside the scope of the subject, so I won't be going into that. But yeah, that was just an input error, so it's supposed to be minus 5, and there we get the values that we're supposed to get. Alright, so thanks for listening. In the next screencast, we'll be going through how we can make some charts.